Greetings Year 11 students and welcome to another exciting class of mathematics. Today we're going to be looking at logarithms, and it's important you understand there are two logarithm buttons on your calculator. Now if you get your calculator and have a look at it, on the right hand side towards the top you have a button that has log written, and you have next to that another button that has ln. Some people think it's in, it's ln. That is another logarithm button. It's actually called the natural logarithm, but we're not going to be using it now, but I just want you to understand that it exists. We're going to be using log to base 10. Now the log button really means log to base 10 of a number. We only write it as log x, but it's assumed that you understand a 10 is there. It's a little bit like when I do this. If I'm writing the square root of 25, it's assumed that you understand that there is a little 2 there because it's the square root of 25. If I write x, it's assumed you know it's x to the power of 1. Same concept, or it's even 1x to the power of 1. When you see the term log of, say, 5, it's assumed that you understand that it's log to base 10 of 5. Now what are logarithms? Well, we'll get to that in a second. But you need to understand the term first and what the buttons are. Now you need to remember also that log is short for logarithm. ln is short for the natural logarithm. So we could get on the calculator, and we will. If you get on the calculator, you can hit the log button. So if you hit log 5.7 and then push equals, you'll get an answer. And the answer is 0.7558748,557. If you wanted to, and we'll just do one of these for the sake of using the button, log to base e means push the ln button. So push ln of 2.9 and then push equals. You can close the bracket, you don't need to. And you will get 1.064710,737. Now both of those answers have been rounded off on the calculator. What do they mean? Well, we'll find that out in a moment. But before we actually discuss logarithms, we want to understand that when you write something, you can write it, if it's an equation, in a logarithmic form, or you can write it in an index form, or an exponential form, or a power form. And if you know something in logarithmic form, you can change it to index form. If you know something in index form, you can change it to log form. So we're going to have to address that in a little while. But what are logarithms? So let's talk about what a logarithm is. First of all, using the word logarithm is actually probably a bit of a mistake, but they do. Let's play a little bit of a game. I want you to think about this. I want to say, what power do I put above the number 2 to get the answer 8? That's the question, and that's the way. What power do I put above the number 2 so I get an answer of 8? And hopefully you can think of it as 2 cubed is 8. 2 times 2 times 2 is 8. Let's try that again. What power do I put above the number 5 so I get an answer of 25? Well, 5 squared would give 25, so 2 would be the power I have to put above 5 to get the answer of 25. Let's try this again. What power do I put above the number 3 to get an answer of 1? Well, anything to the power of 0 is 1, so 3 to the power of 0 would give 1, so the power I put above the number 3 would be a 0 if I wanted the answer to be a 1. And one more, what power do I put above the number 10 to get an answer of 1 million? Nice big number. Now, hopefully you know 10 times 10 times 10 times 10 times 10 times 10. I think I said 6 of them. equals 1,000,000. So 10 to the power of 6 equals 1,000,000. Now, if I didn't write the word power, I wrote this instead. The log to base 7 of 49. What that means is, what power do you put above the number 7 to get an answer of 49? And I do know that 49 can be written as 7 squared, so the power I put above the number 7 must be a 2 if I want the answer to be 49. That is how logarithms work. Now, logarithmic scales are unusual when you compare them to linear scales. We use them when we're measuring earthquakes. We use them in a whole host of things. They are very powerful, and I'll get into that in more detail with you later, but I needed you to understand that logarithms are just dealing with powers. Now, because we have on our calculator a logarithm button to base 10, if I wanted to do this question here, log to base 10 of 1,000, I could do that on the calculator and it would say the answer is 3. And the reason it says the answer is 3 is because 10, when I raise it to the power of 3, gives 1,000 as the answer. Now, if you actually understand that logic, you could say, when I look at that, I know 10 to the power of 3 equals 1,000. I've changed this question now. I've taken something that was written in log form and I've changed it into index form. If I see something written in index form, I could actually change it back to log form. Let's try doing some questions. Now, when you look at these questions, I'm going to introduce a new concept, and I'll just write it here. I'm going to say a to the power of m equals capital X, and I'll go log to base a of x equals m. That's like the rule we're going to use. And what I want you to understand is the language I'm about to introduce. If something is written in index form, the number underneath the power has a special name. It's called a base. If I write something in logarithmic form, the little number that's underneath the g has a special name. It's called the base. So when you're dealing with index form and logarithm form, there are bases there. And it's the base that we're interested in. And I'm going to play a game called slide the base, or sliding bases. You won't hear that technology or that term, in your textbook, but let's see if we can make sense of it. Now, looking at one part A, it's a question written in index form. I want to write it in logarithmic form. So I look at the base. The base is 2. So I'm going to slide it over to the other side. And if I slide it over to the other side, the 5 is just left by itself because the 2 got slid to the other side. I've slidden. I moved 2 to the other side, and it's a base. So because it's a base, it has to stay a base. And because I'm changing it to logarithmic form, it has to be a base for the logarithm. And that has now rewritten 2 to the power of 5 equals 32 in logarithmic form. And let's think about it. What power do you put above the number 2 to get an answer of 32? You put a 5 above it because 2 to the power of 5 equals 32. Let's try the next one. I slide the base. The base is a 5, so I'm just left with 3 equals. If I slide the base and I'm turning it into logarithmic form, the base now has to be with the logarithm, and it's 125. So I've changed from index or power form into a logarithmic form. Let's work back the other way with example number 2. This is already written in log form, and I want to change it to index form. So when I look at the question, I can see that the logarithm has a base of 3. The base is what gets moved, so I'm going to move the base to the other side, and because I'm changing from log form to index form, the log just disappears. So I'm just left with 81 because the 3 got moved to the other side, but it's a base. And if it's a base, it needs to stay a base. So the 3 gets moved across to the other side and it's a base. And if you actually look at the question, you'll see that the 3 is just a little bit lower. It's the bottom of the G. It's underneath the 4. It stays underneath. It stays in its low position. So that's changed from log form to index form. We look at part B. The bases are 10, so we're going to slide the base. So we'll get 1 million, 1 million equals, the base is 10, it's 10 to the power of 6, and we've changed from log form to index form. Now, question 3 says we've actually got to get an answer. So if I look at question 3, find the following. Now we're going to do this without a calculator. Remember, logarithm is just a way of writing a power. What power do you put above the number 2 to get the answer 16? So what power do you put above the number 2 to get an answer of 16? Well, I know 16 is 2 to the power of 4, so you must put a 4 above the number 2 to get an answer of 16. Part B. What power do you put above the number 10 to get an answer of 10,000? Well, I know 10 to the power of 4 is 10,000, so the power I put above the 10 would be the number 4. Looking at question 4, we actually have to solve each of these equations and their logarithmic equations by changing them first into index form. So let's do that. The index for part A, below the log, below the G, you can see there's a number 5. So I slide that across to the other side and I get 5 to the power of x equals, and I'm just left with 1 over 5 because the log disappears when you're changing from log form to index form. Now 5 to the power of x will now equal 5 to the power of negative 1, because 1 over 5 is 5 to the negative 1. The bases are the same, which means x equals minus 1. Looking at part B, slide the base, the letter below, the number below the letter G, 27. So we slide it across to the other side. And I'm just left with an x now because logarithm disappears when I slide the base. What we do need to remember is that to the power of 1/3 is a fancy way of writing cube root. And the cube root of 27 is 3. Part C, slide the base. So if we slide the base, we're left with 12 equals x to the power of negative 1. There's several ways you could do this. I'm going to choose to do it this way. I'm going to raise both sides to the power of negative 1. If I do that, on the left-hand side, I get 12 to the negative 1, which is another way of writing 1 over 12. On the right-hand side, I have a power to a power, and what's minus 1 times minus 1? Plus 1. So it's just x to the power of plus 1, or x equals 1/12. Part D, going to slide the base across. The base is the number under the letter G, which is x, so I'm left with 9 equals x to the power of minus 2. Well, a lot of different ways you could do this question. I'm going to do it like this. I'm going to say, a little bit like working with perpendicular gradients. I'm going to say the reciprocal of 2 is 1 over 2. So I'm going to raise both sides to the power of minus 1/2, because I know a reciprocal multiplied by the original will always give 1. Let's just check this out. On the left-hand side, I'm left with 9 to the power of minus 1/2. Well, 9 to the power of 1/2 is the square root of 9. 9 to the power of minus 1/2 will be 1 over. the square root of 9. When I look at the powers, in this on the right hand side I have x to the power of minus 2 and minus a half. Times them together. Minus times a minus gives a plus. 2 times a half, it's a reciprocal. A reciprocal in its original will always give 1. A half of 2 is 1, so you get x to the power of 1. Which means x equals 1 over the square root of 9 or 1 over 3. So a little bit challenging. Here's another way you could have done that if you don't like that approach. You could have written 9 equals x to the power of minus 2, which is 9 equal to 1 over x squared times the x squared across to the left-hand side. Divide both sides by 9 and take the square root of both sides. Normally when you take the square root of both sides, you've got the plus case and the minus case to consider. But one thing that we haven't discussed yet when you're dealing with logarithms, the base can never be negative. The base must be a positive number, so in this case it has to equal plus a third. Probably a bit easier to use this approach. Okay, question 5 asks us to change to a log equation from an index equation. So let's go through the process. Now, when I look at 5 part A, the base is a 10. So the 10 is going to slide to the other side. So if the 10 slides to the other side, I'm just left with x. If the 10 has slidden to the other side, it now must be log to base 10 because it's a base of 125. Now, looking at that, I have a log base 10 button on the calculator. So let's just push that. So you just go on your calculator, you go log 125 and push equals, and you'll get 2.096910013, and that's rounded on the calculator screen. It actually goes more than that, but that's fine. Let's try part B. The base is a 10. So if I slide the base, I'm just left with an x equals log to base 10 of 0.123. Well, I have a log to base 10 button on my calculator. So on my calculator, I'll go log of 0.123, push equals, and you'll get minus 0.9100948886. So if they are log to base 10 questions, you can use your calculator. Time for you to do some questions. Enjoy the experience. Bye for now.